Geography optional at Vajirao and Reddy Institute. Today we are going to discuss a topic called as physical conditions of Earth's interior. So this is a topic in geography optional, physical condition of Earth's interior, and in this topic what we need to study is that number one, what are the sources of studying the Earth's interior? Number two, how we have the knowledge of Earth's interior. Number three, what is our knowledge of Earth's interior? How Earth looks like, Earth's interior. And then finally, what is the reason why we have studied all these things? What is the reason? What is the reasons why we have studied about all these things? So these are the things that we need to cover in this topic. So first of all, the sources. When we say these sources, there can be two types of sources. One source can be artificial, another source can be natural. So artificial sources can be there, natural sources can be there. The artificial sources, when we say the artificial sources, so the artificial sources, what are these? These are like pressure of the earth, pressure, temperature, density. By studying these things, we can get some information about the interior of the earth. There are as well as some natural sources. The natural sources includes number one, volcanicity and seismicity. So volcanicity and seismicity. The problem with volcanicity, there is a problem attached with volcanicity, and the problem attached with volcanicity is that we don't have very nice information that can be there with the help of volcanicity. Because what happens when a volcano erupts? Well, what happens when a volcano erupts? A volcano erupts and it gives out like magma. It gives out magma. So it gets very limited information about the Earth's interior. Then how we can come to know, how we can understand like what is the condition of Earth's interior. So here seismicity comes to our rescue. The seismicity is the science which deals with the earthquakes and earthquake waves. So this is the science that helps us to understand the physical conditions of the Earth's interior. Out of all these sources, seismicity is something that helps us to know what are the conditions, how the Earth's interior looks like what is the interior, like physical condition of it. Is it solid, it's liquid, or whatsoever. So it is basically the seismicity by studying the earthquake waves. At international level, which organization studies the internal structure of the earth? At international level, the organization that deals with the study of internal structure of the earth is International Union of Geodesy and Geophysics. So this is the organization, this is an international organization that deals with the study of the Earth's interior, and this organization, it also takes seismicity or earthquake waves as the basis of study about the physical conditions of the Earth's interior. So this will be our background. Now we'll move on to the body of the answer. So how earthquake or earthquake wave, they can help us to know about physical condition of Earth's interior. Now just see this. This is a model of an earthquake. What happens when an earthquake comes? So like this is an earthquake. the point at which the earthquake, like origin of earthquake is there, it is called as focus. It is also called as hypocenter. Hypocenter or focus. Now from focus, what happens? There are various waves, as you can see in this figure. There are various waves that travels in all directions. There are various waves that travels in all directions. When these waves, the point on the surface of the earth perpendicular to the focus, that means this will be the point where earthquake waves will be reaching, like first. This point is called as epicenter. Epicenter. When the earthquake waves reaches at the epicenter, what happens from here, different types of waves, they again like starts. So two types of waves. One waves are traveling inside the body of earth. Inside the body of earth. Another type of wave are traveling over the surface of the earth. This is the surface. So we can come to know one thing, that seismic waves are of two types. One is body waves and another is surface waves. As the name suggests, body waves will be there inside the body here, surface waves over the surface. Now body waves, there are two types of body waves. When we say body waves, there are two types of body waves. One are P waves or primary waves, another are S waves or secondary waves. So P waves and S waves, these are the two types of body waves. Now what we need to do is, we need to understand these waves first, and after studying the characteristics of these waves, we will come to know what is the physical condition of the earth's interior. That's a very simple thing that we can do, just to understand what is the physical condition of the earth's interior. Okay, so now first we will see what are P waves and how P waves travels. So this figure, it shows how the P waves propagate. How the P waves propagate. In this figure, it is visible that the particles of the wave, they are traveling in to and fro motion. To and fro motion in the direction of propagation of the wave. In the direction of propagation of the wave. Okay, so the particles of P waves, how the particles are moving, they are doing like this, to and fro, and like this, by doing like this, they are moving ahead in the direction of propagation of the wave. What are the other characteristics of P waves? What are the other characteristics of P waves? So P waves, they are having many characteristics. P waves are having many characteristics. They are called as primary waves. That means they must have been like most important waves. Actually, these are the waves which reach. These are the waves which are recorded at epicenter, like first. That means these are the waves having maximum speed. These are the waves having maximum speed. These are the waves having maximum speed. Okay. Now these waves, the particles of the waves, they vibrate. They vibrate. How they vibrate? How they vibrate? To and fro. They vibrate to and fro. Now these waves, they can travel in any medium. Very important thing. These waves can travel in any medium, whether it is solid or liquid or gases. They can travel in any medium. But there is a point. The point is, the velocity of these waves is maximum in solids, it reduces in liquids, it further reduces in gases. Now this is a very important point. This point will be used in assessing the conditions of the Earth's interior. Okay. So these waves can travel in all mediums, but the velocity is maximum in solids, it reduces in liquids, and finally it further reduces in gases. Okay, it reduces in gases. Now this is something very important. These waves are also called as longitudinal waves or compressional waves or primary waves. So these were the P waves. Now coming on to the S waves, another type of body waves. S waves. S waves, now just like from this figure, it is clear that S waves, these are not traveling in a to and fro motion. These are not traveling like this. These are not traveling like this. These are traveling, the particles of these waves are moving at right angles. The particles are moving at right angles. You can see how the wave is moving. How the wave is moving. They are moving at right angles, in the direct, like right angles to the direction of propagation of the wave. Okay, so the S waves travels in a different way, and the speed of S waves is lesser than the P waves. There is one very important characteristic that is linked with the S waves, and that characteristic is that these waves, they travel only in solids. Only in solids. This is very important characteristics that is related with these waves. Okay, primary waves, P waves, they were traveling in any medium. Their velocity was maximum in solids, but they were traveling in any medium. S waves, they are traveling only and only in solids. Okay, this is the most important characteristic of these waves. Finally, we are having another type of waves that are traveling over the surface of the earth. And these are called as L waves, because these are traveling over the surface surface of earth. Two things are important. One, they will not be very helpful in telling us the conditions of Earth's interior. Okay, not very helpful. Okay. Second, because they are moving over the surface of the earth. This is the surface of the earth, these are the buildings, and these waves are moving over the surface. So these will be the waves which will create maximum destruction. Okay, maximum destruction, loss of life and property will be maximum because of these waves. Though these waves are not very much helpful in understanding about the Earth's interior. Okay, now we know that P waves and S waves, we know the characteristics of P waves and S waves. Now we will infer something. After studying these characteristics, now we will infer something, inference. We will take some inference, and we will take some inference that if the earth would have been a homogeneous body, if the earth would have been a homogeneous body, these waves must have traveled in the straight path. These waves must have traveled in the straight path, but that is not the case. When these waves are recorded on a seismograph, okay, when these waves are recorded on a seismograph, the recordings show that the waves, they take curved and refracted paths. Curved and refracted paths. This shows that Earth is not homogeneous. We are now very much sure about it that Earth is not homogeneous, because seismic waves, they are taking curved and refracted paths. Okay, because these waves are taking curved and refracted paths. So now we are very much sure that these waves are, the Earth is not a homogeneous solid. Okay, now if it is not a homogeneous solid, then what it is? Now we will see the characteristics of these waves when the waves passes through the interior of the earth. Okay, just give a look at this graph, very important graph. In this answer, this will be the backbone. This graph will be the backbone of the for this answer. Now see what is happening. This line is showing like P waves, how P waves is traveling. Okay, this line is showing how P waves are traveling. This is the velocity, okay, and this is the depth. As we can see here, this is the depth. Now we'll see how the P waves, P wave it is traveling. If P wave is like it's starting from here, okay, then the speed of P waves increases. We can see the velocity is increasing. The speed of P waves it increases. When the speed of P waves increases, now what happens? There is an area here. There is an area here. Here in this area, the speed of P waves decreases. The speed of P waves decreases. Accelerator is down. And before that, the P waves they were taking off. Like they were taking off. And what happens is like a very small, you can say very small breaks, a small road breaker is there, something of that kind, or you can say there's some like the speed is reduced. When the speed is reduced, that means there is something not very much regular here. What is that? Scientists they confirmed that this is a layer where the earth is made up of semi-solid or semi-liquid. Same thing, semi-solid or semi-liquid. Low velocity zone. This layer is called as low velocity zone. Low velocity zone. Okay, now what happens? Still the P waves they manage to cross this. As soon we can see, as soon it's come out of this zone, the speed again starts increasing. It's like again taking off, and then suddenly what is happening at a specific depth? This depth is around 2900 kilometers. This depth is around at 2900 kilometers. What happens is sudden brake. It's something like you are driving a car and there is like someone on the road in front of you and you are applying sudden brakes. That means there is something discontinuity types. Either the road is broken or someone has come in front of your vehicle, something of that kind. Okay, so the speed reduces drastically. You can see the drastic reduction in the speed. Now scholars opined that the uppermost part, it was the crust. Where the speed of P waves it has decreased, a small decrease. That was asthenosphere. It is also called a low velocity zone, over which the plates are moving, over which the lithospheric plates, the slabs, they are traveling, they are floating, they are moving over asthenosphere. Why is this reduction of speed here? That means it is altogether a different zone. It is a different zone. And then scholars, according to scholars, this is outer core. This is the outer core. Now just see what happens. Okay, the P waves they are able to pass on through this. Now the scholars they thought why the speed decreased drastically. Something is there. They must have recorded this and a side में like this star mark and the speed reduced drastically, something like that. They must have taken a note of it. And finally what they found, like again at a layer the speed increased and then the speed is constant. They again found that there is something, again there is a discontinuity, which is present after this, like within this core or after this outer core. Now we will see about S waves. Now this is the line for S waves. You can see this is the curve. Now S waves again they started, the speed is less than P waves. You can see speed like P waves and S waves, the speed is less than P waves. The S waves it started. When S waves started, again the speed is reduced. You can see here, the speed is reduced. So what the scholars have opined, low velocity zone, they have given their ratification. Yes, this is the low velocity zone. Okay, come on. But still S waves which were not able, there is a characteristic of S wave, they are not able to pass through liquids. We know that. But because it was semi-solid type of a thing, they managed to pass through it. After that they entered into the mantle, and then suddenly at a depth where the P waves had applied sudden brakes at that point, at that depth, the S waves disappeared. Mr. India, S waves disappeared. There are no S waves after this depth, 2900 kilometers, they disappeared. And we know that S waves don't travel in liquids. What will be the inference that we can draw from here? Very simple inference that we can draw from here is that this layer is made up of liquid. The outer core is liquid. Now, because once S waves has been disappeared in outer core, they cannot re-enter inner core. No, not allowed. Once you are not able to clear the prelims, you cannot appear in interviews. It's so simple. Once you are not able, you have not managed to pass the outer core, now you cannot enter the inner core. So there are no S waves in the outer core as well as in the inner core. So what is the information that can be inferred from this graph? From this graph, what is the information that we can infer? That there are various zones. Earth is having various zones. Earth is divided into various zones. From the crust to the core, the Earth is divided into various zones. These zones are called as crust, mantle and core. Crust, mantle and core. I can show you with another picture for this. This is the better one. The crust, mantle and the core. Now, scholars, they have given certain names for the discontinuities. They have given certain names for the discontinuities that are present between the crust, mantle and core. Okay, like things are not continuous like in a continuum. There is a breakage there. There is a breakage. So between the crust and the mantle, there is a discontinuity called as Moho discontinuity. Moho discontinuity. It was discovered by Mohorovičić, so it is called as Mohorovičić discontinuity or Moho discontinuity. The discontinuity between mantle and core, this is called as Gutenberg discontinuity. Gutenberg discontinuity. Moho discontinuity between crust and mantle, and Gutenberg discontinuity between mantle and core. Now fine, later on the scholars, they opined that the core, it is also divided like outer core and inner core. The outer core is liquid. But because the speed of P waves, it started increasing in the inner core, that means it is solid. It is solid because of the intense superincumbent load. The pressure, the weight of the material that is overlying the crust, okay, that is overlying the core, mantle, crust, everything. So this is solid again. So scholars opined that the discontinuity between outer core and inner core, this discontinuity, there is again a discontinuity here, that is called as Lehman discontinuity. Then, as you know that research, the research goes on and on. So the scholars, they were of the view that this crust is also divided. There is a discontinuity between the crust also. Okay, there is a discontinuity between the crust also, and that is called as Conorode discontinuity. As well as mantle, it can be also divided upper mantle and lower mantle. This discontinuity is called as Repetti discontinuity. This question can be asked in exam, in even prelims this question can be asked. Arrange the discontinuities from the crust to the core. Okay. So now we know that this is the physical condition of the earth, and how we have been able to know this thing, that is because of the seismic waves. Now the final question, the last question, why? Now the last question, why? Why we have studied all these things? The question is like something like it must come to our mind. What is the reason why we are doing that, and why man is not entering inside the earth? Why man is not entering inside it? It is not the case that man has not tried. Man has tried. Man has tried. Man has tried. You know, like the maximum depth to which man had entered into the earth is a meager, only and only 12 kilometers. 12 kilometers. That is the maximum depth to which the man has entered. And we say we are living in an era of possibilism. Okay, that is the only depth. Okay, the place is situated in Russia, Sakhalin 1. Sakhalin 1. It is called as Kola Super Deep. Kola Super Deep. Okay, but again the question, why we are studying all these things? Why we are studying all these things? We are studying all these things because we want to understand the conditions over earth and what is going on inside the earth. Because what is going inside the earth is affecting us. It is affecting us. It is affecting us in the matter like it is affecting us by volcanicity, it is affecting us by seismicity. Sometimes somewhere like we are having a volcano. We know that very recently volcano has like it has bursted at like in a Tonga, Pacific Ocean, Tonga, very recently. And what had happened after that? Okay, also seismicity, like sometimes here, sometimes at the other corner of the world, we are having like earthquakes, so many earthquakes. So if we want to understand what is happening inside the earth, first of all, we need to understand the basics of the interior of the earth. The International Union of Geodesy and Geophysics is helping us greatly, immensely in this regard. Also, if we want to have the information about the mineral resources which are present inside the earth, mineral resources, if we want to understand, if we want to get to know the information about this, again the study of interior of the earth is very, very important. So that's all for this topic. We'll be meeting again someday. Bye bye. Thank you.